Okay, Wildcats. Today we're going to solving exponential and log equations part 1 on page 58. Solve the equation using same base check. All right, so the first step is you want to make sure that they are the same base. If they are the same base, the exponents are equivalent. So since the bases are the same, the exponents are equal. So we can say that 8x equals 7x plus 12. Now at this point, you're going to solve. So we're going to subtract 7x. 8x minus 7x is 1x. 7x minus 7x is 0, so 1x equals 12. Okay, at this point, we're going to check to see if x equals 12. And we're going to use our calculator to do so. Okay, so we're going to go to On, New Document, No, Add Calculator. And we're going to plug in 12 into the left side and the right side. So that's 2 up key 8 times 12, click to the right, equals 2 up key 7 times 12 plus 12. You can see here that it says true. So it checks. Now that's one way to do it. Or what you can do is plug the right side in, and you can plug in, the left side, and then plug in the right side. And you can see here that the left side is equivalent to the right side, and you can put 79 ... is equal to 79 ... since the number is so long. But either way, it checks. Okay. So now let's take a look at example 2. Okay. Now here you see the bases are the same. Log base 4 and log base 4 are the same. So what we need to do is actually raise both sides by 4. Okay. And what that does is this makes this one and this one. So now you can say that negative 5x is equivalent to negative 7x plus 10. Now at that point we're going to solve. So we're going to add 7x to both sides. Negative 5x and 7x is 2x equals, that's 0, 10. Divide both sides by 2. X equals 5. Okay, now at this point we're going to check x equals 5. Now I showed you that you could either do true or find the left side and the right side. I'm just going to do the left side and the right side throughout the video, but you can also do the true. Okay, so here we're going to check. So we're going to go to On, New Document, No, Add Calculator, and we're going to plug in 5 into the left side and into the right side. So we're going to do Control log base 4 of negative 5 times 5. Now you see you get error. Okay, now let's try the right side. So Control log base 4 of negative 7 times 5 plus 10. You get error. So error equals error, but the problem is, since it's an error, we would say that x equals 5 is an extraneous solution. Okay, all right, so go ahead and finish up example 2. Now let's take a look at example 3 and let's see if we can get some better lighting. There we go. All right, now here it says solve each equation by taking the log of both sides. So what we're going to do is, since the base is 3, we're going to take the log of base 3 of both sides. So log base 3 of 3 to the 2x. Now, you can do whatever you want as long as you do it to the left and right side because of the equality. So because we did log base 3 of the left side, we're going to do log base 3 to the right side. So log base 3 of 25. Now, the reason we did that is because the log base of 3 becomes 1, and you're left with the exponent. So we can say that 2x equals log base 3 of 25. Now we're going to divide both sides by 2. So then, now when you divide by a fraction, you multiply by the reciprocal. So that's actually technically 2 divided by 1. So x equals log, well, actually, you know what? You can just leave it like that. It looks ugly, but it is actually probably just easier to leave it like that. Now, let's go ahead and find the decimal, though, for that. Okay, so to find the decimal, we're going to plug that into our calculator. So we're going to do control divide. Let me see if I can decrease the calculator brightness a little bit. All right, so we're going to do control log base 3 of 25 divided by 2. Center, so that's 1.46. Let's just say it's 1.5. Okay, so we need to check x equals 1.5. Now, another way to check is we can graph the left side and the right side to find the solution. So let's do that. On new document, no, we're going to add graph. We're going to graph 3 up key 2 to the x, tab 25. Now, we want to find the intersection, so we're going to go to menu, window zoom, zoom out, and click once, twice, 3 times. You can see that they intersect. And let me see if I can change the lighting a little bit. There we go. It's about as best as we can probably get. Maybe if I brighten the calculator. That's probably as good as we can get. Now, press escape, menu, analyze graph, intersection, click, move the cursor to the left, click again, and slide. And you can see that they intersect at 1.46, which we rounded to 1.5, so that checks. Okay. Now, there's another way to check it, okay, is if we plug in that, which gets much more complicated, but I'm going to show you for those of you who think you like that method. So we're going to go to new document, no, add calculator. So we're going to do 3 up key 2 and then times control log base 3 of 25. Oh, actually, hold on. Control divide. Almost forgot about divided by 2. Now control log base 3 of 25 divided by 2. So we get 25 equals 25, and it checks. So again, you can kind of decide which method you like to use for checking. Okay. Now let's take a look at example 4. Okay. Example 4 and example 3 are similar. Here we did log base 3. We're going to do log base 5. So we're going to take log base 5 to both sides. Okay. Now when you do that, this becomes 1. You're left with x minus 2 equals log base 5 of 200. Going to add 2 to both sides. So x equals log base 5 of 200 plus 2. And let's find the decimal. So x equals, so to find the decimal, we're going to plug that into a calculator. So control log base 5 of 200 plus 2 is, let's just say, is 5.3. All right, so now we need to check x equals 5.3. Now, I showed you how to check by graphing in the last problem. This problem, I'm just going to plug in the log base 5 of 200 plus 2 to check to see if it's correct. Okay, So to do that in your calculator, let me delete this. We're going to do 5 up key, control log base 5 of 200 plus 2 minus 2. You can see that 200 equals 200, so it checks. Okay, go ahead and finish up example 4. All right, now let's take a look at example 5. Solve the equation by using log properties and check. So here, when it's subtraction, the log arguments divide. So this is log, and if there's no base, we assume base 10. So log base 10 of 45x divided by 3 equals 1. Now, using the same logic here, log base 3 of 3 or 4 of log of 4, it's actually more like this logic. We're going to do by the power of 10 to both sides. And what that does is that becomes 1, and you're left with 45x divided by 3 is 15x equals 10 to the first power is 10. We're going to divide both sides by 15. So x equals 10 divided by 15, which reduces to be 2/3. Okay, so now we're going to check x equals 2/3. So to do that, we're going to plug 2/3 in for x. So we're going to press Control log, and remember we said base is 10, of 45 times 2 divided by 3 minus Control log base 10 of 3 is 1. So 1 goes 1, so this checks. Okay, go ahead and finish up example 5. Okay, now example 5 is finished. Let's take a look at example 6. So here, when you have addition with logs, you multiply. Remember, if there's no base, it's base of 10. So this becomes log base 10 of 2 times x plus 9 equals 1. Same logic here. We're going to make both sides base of 10. This becomes 1. You're left with 2 times x plus 9 is 2x plus 18 equals 10. Okay, subtract 18 from both sides. So 2x equals negative 8. Divide both sides by 2. X equals negative 4. Okay, so now we need to check x equals negative 4. We're going to plug that number in for x. So control log, remember if there's no base, we assume it's 10 of 2 plus control log base 10 of negative 4 plus 9. 1 equals 1, so this checks. Okay, go ahead and finish up example 6. Okay, now example 6 is complete. Let's take a look at example 7. Okay, now here, log base 4, so we're going to do the base of 4 to both sides. That leaves x squared equals 4 to the 7th power is 16,384. We're going to take the square root of both sides. Now remember, square root is plus or minus. So x equals, we do the square root of 16,384 is a positive 128, and x equals negative 128. Okay, so let's check x equals 128 first. Okay, so we're going to plug that into your calculator. So control log base 10, 4, sorry, of 128 squared, you can see equals 7. So 7 equals 7. So it checks. Okay. Now let's check x equals negative 128. Okay, so again with our calculator, so we're going to do control log of base 4. When you square a negative number, it needs to be in parentheses. And you can see it equals 7. So 7 equals 7. So they both check. Okay, last example. Okay, again, base is 3, so we're going to make 3 here. This becomes 1. So then you're left with x minus 5 equals 3 squared. Excuse me, let me hang up that telemarketer phone call. All right, so we're going to add 5 to both sides. So x equals 14. Okay, now we need to check x equals 14. And we're going to do that with our calculator. So let's delete this work. And then control log base 3 of 14 minus 5. So 2 equals 2. So it checks. Okay, so if you would, go ahead and finish up your examples and start working on our assignment, and have a wonderful Wildcat day.